Hi everyone, so what we have here is a milling machine. So what this basically comprises of is a spindle that holds a cutting tool and then work holding that holds the component, and then of course the spindle is rotating and cutting the part. So the work holding of course is the vise, in this case, that holds the part. We've got quite a large vise on the machine at the moment, but we can also have smaller vices that hold the part. You just make sure that the work holding that you have is suitable for the part you're making. You can also have bespoke work holding that we call soft jaws, and these hold an individual part and they are bespoke to that component. Whereas work holding like this as a vise is a bit more universal and very common in practice. So tools, we've got lots of different types of tools. This is an end mill. So this is called a flat end mill. We have the straight flute or the shank of the actual tool, and then also we have the flat tips as well. This is really good for what we call roughing operations. So removing lots of material very quickly, and it also produces really nice straight lines on the part, on side walls of components. But it's pretty restricted to roughing lots of material or finishing very straight components. We can have different types of tools as well. So let's have a look at another type of tool. What we're going to have a look at here is called a facing cutter. So this cutter has individual tips that are actually screwed into this holder. The end mill we looked at just was solid tungsten carbide, whereas on this tool the body of it is steel and then just these tips are tungsten carbide. Now this produces a really high surface finish on flat faces. It's called a facing cutter. If you want to make curved surfaces, you use something called a ball nose cutter. So what we see here looks very similar to the end mill we looked at first, but rather than having a flat edge to it, we have a complete radius that goes all the way over. That's called a ball nose cutter. This is really good at creating complex free-form surfaces where it will go across the surface and produce a really nice finish. These are very slow to do that though, so we only normally use these for the finishing operations. There are lots of other tool types. We have drills, we have reamers, we can also have probes fitted to machines that help in setting up our component and also in inspection. So what we have here is quite an interesting machine. So this machine started out life as a 3-axis machine. So that is 3 linear axes. We have the x-axis, like we've just seen, that goes left to right. We have the y-axis that goes front to back. And then the z-axis that goes up and down. But what we have here is something called a trunnion that's been bolted to the original table of the machine. Now what this allows us to do is add additional axes and make more complex parts and different orientations. So I can move the A axis, which is a rotary axis now. And I can also move the C axis, which is another rotary axis. So what we can see there, we have 2 additional axes bolted onto the table. So this machine now is a 5-axis machine, and it's called a table 5-axis. And that's because both rotary axes are on the table. They're not on the head of the machine. If this head was to pivot and rotate, then it would be called a head-head machine. And as you might have guessed, you could also have a combination of a head table, where the head moves and also the table moves. So what we can see here, we have multiple different tools, multiple different axes, all moving together in unison to create our components. So how do we actually make parts? We're going to have a look now at some toolpaths inside of Fusion.
We can see here the toolpaths visualised within the Fusion 360 application. We can see the path the tool will take across the part, and the cutting motions are displayed in blue. We can also look at further information such as machining time, tool changes, and look at overall analytics of that toolpath. All the toolpaths are contained within the browser, and multiple setups can also be present within the same component. This allows for the machining of both sides of a component. Once you have the toolpaths created to machine the part, we can simulate the path these will take and look at the removal of the stock itself.